Hello friends, today we will discuss about the top introduction of fluid mechanics. Here we will discuss on the basic definition of fluid. What is a fluid? A fluid is a substance or a material which is capable of flow. Hence write it down. It is a substance which is capable of flowing no matter how small shear stress may be. Hence, it is the basic definition of fluid substance which is capable of to flow no matter how small shear stress may be. Hence, the next topic we have to study is about viscosity. Viscosity, it is denoted by mu, and is another name is dynamic viscosity. It is also known as dynamic viscosity. Here, it is defined as the property by virtue of which a fluid offers resistance to the movement of one layer of fluid to the adjacent another layer of fluid. Hence, writing it is defined as the property of a fluid, property by virtue of which a fluid offers resistance to the movement of one layer of fluid but adjacent another layer of fluid. Viscosity comes under the following case. It according to the viscosity diagram, we have this is the topmost layer of fluid, this is the second last layer of fluid, and this is the third last layer of fluid. Here this distance is dy, this distance is dx, or this distance is du. Sorry, this distance is du. This fluid, this layer is moving with velocity u, and this velocity is moving with u plus du, and the distance between these two layers is dv or dy, and this is the y-axis and this is the velocity. Viscosity comes under the following cases. First point is cohesiveness of molecules. Second one is molecular momentum exchange between layer. And so here we discuss about it, the fluid and its viscosity. Viscosity is nothing but it is the property by virtue of which a fluid offers resistance, one layer of fluid offer resistance to the another adjacent layer of fluid. Second is Newton's law. Second topic we have to study is about Newton's law of viscosity. Viscosity. According to this, the shear stress according to it, the shear stress tau is directly proportional to the velocity gradient. So now, according to this law, shear stress tau is directly proportional to the velocity gradient. It implies shear stress is directly proportional to du by dy, where, and after opening it, shear stress equals to mu into my du by dy, where tau is the shear stress, mu is the viscosity or dynamic viscosity, and du by dy is the velocity gradient. Hence, the question also is asked in the exams about the difference between Newtonian and non-Newtonian fluids. It is not so difficult. Newtonian fluid, and second one is non-Newtonian fluid. First difference is shear stress is equals to mu du divided by dy, and the second, it follow Newton's law of viscosity. Here it follows power laws. It follows power law. Here shear stress is equals to shear stress or yield shear stress plus k du divided by dy raised to the power n, where tau is the shear stress, tau y is the yield shear stress, k is the consistency index, and small n is the flow behavior index. Also, the example of Newtonian fluids are water, air, petrol, kerosene. The example of Newtonian fluid are water, air, petrol, kerosene, diesel, ethyl alcohol, etc. The last topic we have to cover in the The last topic we have to cover in this video is about properties of fluids, on which various numericals are commonly asked in the exams and is very important in the exam point of view. So first property of fluid is mass density. What is mass density? Mass density, it is nothing but it is then defined as the ratio of mass with respect to volume. It is denoted by rho, and its unit is kg per meter cube. Here mass density, its another name is density, or rho is equals to mass divided by volume. It implies density is equal to m by v. Second property we have to study is about weight density. Weight density, it is defined as the ratio of weight to the volume. It is denoted by small w, and its unit is Newton per meter cube. Specific weight density is equal to capital W divided by volume, is equals to m into g divided by volume is equals to rho into g. Third property we have to study is about specific volume. Specific volume, it is defined as the ratio of volume with respect to mass. It is denoted by Vs, and its unit is meter cube per kg. Vs is equals to volume to the divided by mass is equals to 1 upon rho. Fourth and the last property we have to study is specific gravity. It is nothing but it is defined as the ratio of mass density of tested fluid to mass density of standard fluid. It is denoted by capital S, and it is unitless. Here specific gravity S equals to mass density of tested fluid divided by mass density of standard fluid. It implies S is equals to density of tested fluid divided by density of water, and specific gravity of water is equals to density of water upon density of water is equals to 1. So thank you.